Hello, my name is Walter. I'm a retired professional engineer living here in Orlando, Florida. I'm also a life member of the Academy of Model Aeronautics. I serve as the volunteer director of the Flying Stars Model Aviation program. My fellow volunteers and I have a mission of introducing kids to engineering through model aviation. Our target audience is students from elementary school through college. Today I would like to introduce you to our main teaching vehicle. It is the Flying Star Catapult glider. This model airplane is fun, very inexpensive, and it is well suited to spirited competition, which helps motivate our students to do their best work. The Flying Star design conforms to the rules of the Academy of Model Aeronautics Outdoor Catapult Glider Competition, event number 142, and is especially suited for those under the age of 15 who would compete in the junior category of that event. That would be the 142J then. The Flying Star also provides excellent preparation for high school students who might be competing in the Science Olympiad 2013 Division C Indoor Elastic Launched Glider event. This Flying Star Catapult glider requires no kit purchase. The builder makes his own kit out of readily available basic materials, which helps teach self-reliance, encourages design improvements, and facilitates repairs. So in summary, our goal is to teach youngsters how to design, build, and repair, as well as to fly this model airplane. Normally we believe a 12 to 25 hour course of instruction in the classroom is necessary to achieve this goal, but I will attempt to cover the major points in this video. So this is the Catapult glider, and next we will explore the flight path and how to launch. Before we learn about the design features and how to build our Flying Star Outdoor Catapult glider, let me demonstrate the launch technique and the desired flight path. For launching, we want into the wind, and we want the wind to be less than 10 miles per hour. We hold the launcher in the left hand, whether we're right-handed or left-handed. We put the rubber band on the launch hook, and we hold the launcher straight up, and we want the flight path to be 45 degrees from horizontal, and we want to roll the plane 45 degrees to the right, and then we pull back as far as we can and let go. That's the basic initial launch technique for the first flight. In subsequent flights, depending on the results, for instance, if the wind is on the strong side, maybe 8, 9, 10 miles per hour, perhaps we would take a lower launch angle, more like 20 degrees from horizontal. Or another technique is a straight up launch. So you experiment with those different launch techniques, but initially for the first flight, 45 degrees from horizontal, and always, no matter which launch angle from horizontal, you always want to roll the plane about 45 degrees to the right. Now, for the expected flight path, of course, when we release the glider initially, you're going to have high speeds approaching 80 miles per hour, perhaps 100 miles per hour, and we want basically a half of a loop. And then at the top of the loop, we expect the plane to roll upright and then transition into a left turning glide. And so forth, because our goal is to maximize the flight duration in seconds. So ideally it'll do a half loop. At the top of the loop it'll roll upright, and as it glides, we don't want a sharp glide like that. We want a flat glide where the wings stay pretty much level. And we also want some instability, some pitch instability, so we want a scalloping type of left turn. That's our general objective for the flight path. To truly be successful building and flying our Flying Star outdoor catapult glider, we first must understand the key design features and how they relate to the intended, somewhat complex flight path that I described earlier. The single most important aspect of any airplane is achieving the correct center of gravity. This is almost always 25% of the chord, because most airplanes are intended to meet the specification of straight and level flight. And to achieve pitch stability, 25% is what's necessary. For example, this particular glider is designed to fly straight. By chord, we mean the distance from the leading edge of the wing to the trailing edge of the wing. So if that distance is 4 inches, well then our chord is 4 inches. Therefore, 25% of that, this red line, becomes our intended center of gravity. So if this is 4 inches, 1 inch back from the leading edge of the wing is where we would want that to balance. However, with our Flying Star outdoor catapult glider, we are intentionally creating some pitch instability because we are seeking to maximize our flight time. And we've got a free flight airplane. Once we launch it, we have no control over it. So we need to have the design features create the intended flight path. And of course we desire also to land safely within the bounds of the flying field, and that dictates a complex flight path. Therefore, for this particular design, our center of gravity is located at an unusual tail-heavy position at 55% of the wing chord. For example, on this particular plane, we have a 2.5-inch wing chord from here to here. The center of gravity is located 55% of that to the rear, so that's 1 3/8 inches from the leading edge to the intended balance point. The second design feature we need to be familiar with is the high wing position. The high wing creates stability. Much like this little novelty item intended to hold the business card, it's weighted at the bottom, so no matter how you place it on the table, it will always return to an upright position. And that's the same philosophy that we have here. The wing is on the high part of the fuselage, and we put everything possible below that. Our metal wingtip weight is at the very bottom of the fuselage, as low as we can get it. Of course, the launch hook, even the horizontal stabilizer, is below the wing, and also the rear launch grip. So that creates some stability, which is what we want. A third design feature that's key to this performance of this airplane is polyhedral, which is the fact that the wing slopes up on either side. That also gives us stability, very similar to the pendulum effect of the high wing, which was number 2. A fourth aspect is up elevator trim. On our horizontal stabilizer, the rear portion, the elevator, is bent up slightly. And to show you on a larger elevator, that would mean this is bent up, or even on a larger design, the elevator in this direction, but very slightly. Item number 5 in the design, we have left rudder trim. So this is our vertical stabilizer, this is our rudder, it's bent this way to the left. So again, to get a better look, this would be the direction of trim. Item 6, a key design item is right aileron trim. Right aileron trim means this tab is bent down and this tab is bent up. And the purpose of that is to counteract the tendency for when we have everything turning to the left for the plane to duck under and dive. Right aileron trim helps keep the wings flat as it's turning to the left. Item number 7, to help the rudder turn the plane left, the wing is pivoted slightly to the left. For example, when we build it, if this is the fuselage, instead of the wing being square, we are going to pivot. I'm exaggerating, of course. We're going to pivot and we're going to glue the wing on 2 degrees to the left. Item number 8, we have a slight left wing wingtip bias, which also helps it to turn left, which is simply our decal being on the left wing, makes this wing slightly heavier than this, also helping to turn it to the left. And then design feature number 9, of course, is the Catapult hook, which enables us to use a more powerful launch method. Design feature number 10 is the lightweight. For example, when we choose the 1/4-inch square balsa piece to be utilized for the fuselage, in the hobby store, some pieces are twice as heavy as others. So very careful weight selection is also a design feature. And number 1, the last one I'll mention at this time, is streamlining. And when we get started building in the next step, streamlining first of all involves sanding all the features of the airplane so they're smooth to reduce drag. But also the basic design, the one that we'll be building, you can see has this thin metal weight which reduces the frontal area, so there's some streamlining there, as opposed to design X here, which had a piece of plywood loaded with clay, a more of a blunt design. So the one we'll be building on my right has a more streamlined nose than the one on the left. Okay, finally, we're ready to start building. Okay, let's begin building with construction of the wing. The wing is a unique and key feature of the Flying Star Catapult glider. It's made from a particular hefty brand square dinner plate, usually available only in red. Do not substitute, as I have tried others and Nothing else works nearly as well. So it's the hefty 9.5 inch cut resistant red dinner plate. So what we do, the basic idea is to cut 2 wings out of 1 plate. And the way we do that is, first of all, you can take a square and measure 2 5/8 from one end, make another mark here, connect the line, use a plastic ruler to extend the line over the edge, and then you're ready to cut. And of course the objective is we're going to cut here, and if you do it correctly, your first cut, you'll have this piece here, which is the throwaway, and then you can move it, you can take this piece, move it around to the other plate, mark off another line, or actually it's best to mark it on top, mark off another line, cut that, and then make another line down the center, and that'll give you 2 wings. So, to do the cutting, I'll say that in the engineering community, we have a safety motto that says, all accidents are preventable. So I recommend that everyone wear personal protective equipment when doing work of this nature, which would include, and especially for kids, gloves, dust mask, and safety glasses. Or if a kid wears prescription glasses, then you need to get the wraparound style safety glasses. So once you have your lines, especially for kids, rather than using an X-Acto knife, which is very dangerous, I instead prefer to use the razor saw, particularly with an extra fine blade, which would have 52 teeth per inch. So get yourself a nice stainless steel ruler with cork on the back. Place it along your line, don your personal protective equipment, and then you can proceed to saw until you've made your cuts. Cut it in half, and then you should have 2 of these. At which point, the next step is to measure 3/8 of an inch from here and make a tick mark, 3/8 of an inch from here and make a tick mark, connect those 2 tick marks with a line, and now do that on 4 corners, then get a pair of scissors, cut out the 4 corners, and then your wing should look like this. Now you need to add a center line here on the top, a center line on the bottom, and then you need to draw the right aileron gets drawn on the top of the wing. And the right aileron, this edge is 1 7/8 of an inch from the center. So from here to here is 1 7/8. The aileron itself is 1 1/4 inch wide, or long I should say, and the width from here to here is 3/8. On the opposite side of the wing, draw your left aileron on the bottom with the same dimensions. Following that, 7/16 of an inch from the leading edge of the wing, you need to make a line, because that's where we're going to be mounting our wing brace. To make the wing brace, from the craft store, a 6-inch jumbo craft stick, approximately 1/16 of an inch thick and 3/4 of an inch wide, roughly. You're going to draw a line vertically and cut that in half. And of course you could use the razor saw and the stainless steel ruler to do that, or you could use a heavy-duty multiple cuts with a heavy-duty X-Acto knife. And following that, you should have the basic wing brace. And the wing brace is going to be glued on here. But first, we need to do a very important part of streamlining, reducing drag, by sanding both the wing brace and the wing. So you need to have some sanding blocks. You can make them out of common packing foam, perhaps that you saw with your razor saw. You might put, let's say, a fine 400 grade sandpaper on one side, and maybe a coarse 100 on the other side, or perhaps a 220. Here's a three-sided block, and also you need loose pieces of sandpaper, and I'll show you how to use those. So the idea is to smooth all the edges, leading edges, trailing edges, with this kind of motion. And as you're doing that, you need to grip very close to where you're sanding, otherwise you're going to crease your foam. So move your hands along, and especially when you get here now, that's when you're going to want to switch to this type of to a regular folded sandpaper, and then also, of course, smooth the edges. So all around here, leading edge, trailing edge. Then get your heavier sandpaper, let's say a grade 60, and you need to smooth the top side of this, and in the next video I'll show you what the profile of that should look like when it's properly sanded. So once all that's done, you're going to assemble the wing brace. But one final sanding step before you do that. Of course, you see this says cut resistant, and we're trying to glue something to that. So in the areas where we're gluing the brace, for instance, you're going to sand and rough up that area. And also, where you have your center line on the bottom of the wing, the same thing there. You're going to rough that area up so the glue will stick. Finally, you're going to glue the stick. I use Elmer's glue all. There's maybe two different ways you can glue that stick on there. You can get a balsa building board, or else you can use a couple of thicknesses of heavy cardboard from a box. So you would glue it, and then use these common modeling clamps, which might look like this one or this one. These are modeling pins. This one has a little plastic item to push down. So there we have drying your glued wing brace. Another way to do that, perhaps without using the building board, would be to use clamps. Inexpensive. Affix the glue, or you can even use clothespins to clamp, or even better, you can reverse the clothespin and get a real nice clamp, like so. That completes the basic construction of our wing. To further illustrate the streamlining expected, if we can imagine immediately after we cut our wing a cross section, and immediately after we cut our wing brace before sanding, a cross section of that. Those cross sections would look like the left here. This is the wing cross section, and this is the wing brace cross section. After sanding, to achieve the necessary streamlining, this is what the wing brace should look like, and this is what the wing should be. So, a primary characteristic of successful engineering: precision, perfection, and attention to detail. So the streamlining is definitely an area where, if you pay attention and use due diligence, your efforts will be rewarded in an excellent flying airplane. To finish the wing, after we glue the wing brace, two more steps. One is simply to add a peel-off vinyl type decal to that left wing, which could be your initial. And the second is to finish the ailerons. To finish the ailerons, looking at the top aileron here, actually the bottom will be easier to see. So we put a ruler along that line, and we take a big ballpoint pen, and now we're going to retrace that mark, except we're going to go just a little bit deeper to create just a little bit of a crease. So we're going to score that line. Then, leaving the ruler there and holding it firmly down, we are going to crease that aileron. And actually, previous to that, you would need to have taken a scissors or a knife and cut these two areas. So first you'd cut that, score with the ballpoint pen, and then that aileron down, the right aileron up. That would finish the wing. Next, we are going to create the tail. The first piece of the tail we'll make is the horizontal stabilizer. That's this piece. The rear portion of that, which is movable, is called the elevator. The wing, of course, we made from the 9.75 inch, 9 3/4 inch cut resistant foam. In addition to cut resistant, this foam also resists food sticking. So the cut resistant makes it difficult to cut, so we use the razor saw, and the smoothness makes it difficult to glue, so we sand over the assembly areas. Now we're going to shift to the hefty white everyday plates. These are not cut resistant, so we can cut them with normal scissors or an X-Acto knife. The diameter of these is 8.875 inches. Or you can use an equivalent foam as long as it's 1.5 millimeters thick. So you take a plate, remove the flat center section, and cut the parts out of that, and this can be discarded. So the shape and dimensions of the horizontal stabilizer are as follows: 4 inches wide, 1.5 inches high here and 1 3/4 inches high here. Once you get that cut out, you will further mark it as follows. You will make the elevator line 3/8 of an inch wide. Put the center line, you can see that in red, and then to either side of the center line, 1/8 of an inch over either way, you'll put those lines that I have in blue. That's to help show you where to glue to the fuselage. And then you'll take your sandpaper and you will rough up that area, because that's where we're gluing, and these plates are made so food doesn't stick, and neither does glue, so we need to rough that up. And then at that point, we commence our streamlining the same way we did for the wing. So now, instead of the part looking like this, it now looks like this: smooth, streamlined. It goes from a cross section of looking like this to a cross section that looks like that. That completes, except for one more step. We need to do the same thing we did with the aileron. We need to hold a ruler against that elevator line. We need to take our Bic pen, just a little bit more pressure, just enough to crease it, and then we put it on the edge of the table and we bend it just a smidgen. Just a smidgen of up elevator, barely noticeable. That would be now ready for gluing. The next piece is the vertical stabilizer. The rear portion that is adjustable is called the rudder. So the basic dimensions of that piece: 1 5/8 high, 1 3/4 of an inch long, and then we put a little bevel here, and we mark out 3/8 of an inch wide rudder, and then we do some shaping. So this now, shaping, streamlining, sanding, same sort of techniques. So now we have this. We're going to want to sand over here, because that's going to be mounting on alongside of the fuselage. And then you're also going to score, and we're going to bend this rudder that way just a smidgen. And now that part is ready for assembly. Next will be the fuselage. Okay, now it's time to build a fuselage. What you want to do is go to your local hobby store and buy a 1/4 by 1/4, that's 1/4 inch square balsa stick, 36 inches long, and cut it into 3 12-inch pieces. Then take one of those 12-inch pieces, and now using your razor saw and also the accessory, the miter box, and the 45-degree angle feature, you are going to saw 45-degree angle this way and that way in each end of your 12-inch balsa stick. Then you're going to select one end to be the nose, and on the top of the piece, make a mark here, 3 inches from the tip, make a mark. across the fuselage like so. 2.5 inches back, which is our wing chord, remember, from the leading edge to the trailing edge, make another mark across the fuselage. And of course we're making these marks with precision, perfection, and attention to detail. So now you've got 2 marks across the top of the fuselage, and already you can see our little offset marks in preparation for lining up the center of the wing with that tilt to the left 2 degrees. That's the top of the fuselage. Then on the side of the fuselage, 1 3/8 inches back from the leading edge of the wing, you want to mark your center of gravity point that we discussed earlier. And for illustration purposes, I've shown you where we're going to glue the rear wing. Now let's go to this is the front of the fuselage, to the rear in the bottom. You're going to make a line 1 1/4 inches from the rear. You're going to make a line that shows you where you're going to glue the horizontal stabilizer. Now, with this being the top of the fuselage, you're also going to extend that line around from here to this side, because this is where you're going to glue your vertical stabilizer. And also on the bottom, make a mark 2 1/8 inches back. This is where you're going to glue your front weight. And in between the rear of that front weight and the front of the wing, midway in between, make a plus sign. This is where you're going to drill your hole for your launch hook at a 45-degree angle. Now, it's time for streamlining again. Except for areas that we're going to glue something to. For example, we're going to glue our horizontal stabilizer back here. So do not round this edge or this edge. And the same thing with the wing. Do not round this edge or this edge. The same thing with the front weight. Do not round this edge or this edge. But otherwise, we want to generally streamline and remove all the sharp edges on the fuselage. So, for example, we would get the sanding block and we would, from behind of the wing to the start of the rear hook, we're going to sand that. And then underneath the fuselage, the entire underneath from just aft of where we're going to glue the weight to right before, we're going to go ahead and first start with a coarse sandpaper and then finish with a fine. All that needs to be rounded and streamlined. Then we're going to drill our hole for the launch hook, that plus that we marked there. We're going to start with a small drill, let's say 1/16 of an inch. Now, our launch hook is going to be made out of a 12-inch bamboo barbecue skewer, which is a nice diameter, slightly less than 1/8 of an inch, about 7/64. We're going to cut at a 45-degree angle using our, we're going to cut a piece with one end at a 45-degree angle, 15/16 of an inch long. And of course that piece with that end with the 45-degree is going to be the one we push up through the fuselage so it finishes flush. So you can do it by eye with a simple handheld drill like this, or you can make yourself a jig out of hardwood like I did. So we put the jig in the proper place, we clamp it, and then we're able to drill a more accurate hole. You can see how this works here. So we drill the hole in the center of the fuselage and at the proper angle. After that guide hole of a 1/16 of an inch or so is drilled, then you can get a larger twist drill, enlarge the hole, and perhaps even get a file until you have a nice firm tight hole to insert the piece that you're going to cut for the launch hook. However, do not glue the launch hook in at this time. Now, the first gluing step with the fuselage, I've got go to the hobby store. There's such a thing as craft picks. They're 3.5 inches long. I've darkened one here with a marker, and it's going to glue. Half of it goes onto the fuselage and half of it is behind, and it's flush with the top of the fuselage, and it's going to be glued on like so. That's your rear grip. However, like everything else on the plane, before you glue that, you need to streamline all the parts of it except where it's being glued. So once you get the fuselage marked and streamlined and get the rear launch grip streamlined, you can glue that on there and either hold it with clamps like this, or alternately you can make yourself a nice little pin holder out of one of those pool accessories, or you could even you could use pins like this in that fashion to glue that. When that dries, we get our building board, horizontal stabilizer. We identify on the fuselage. We take a scrap piece of 1.5 millimeter foam, and by the way, the way to be certain you have the correct thickness of foam is to use a micrometer and determine that. So you take a scrap piece of foam so we can keep this level, and you glue and pin like so. When that part is dry, next we take the rudder. Of course, we've sanded there, and we glue the rudder And of course, while we're gluing, precision, perfection, attention to detail, we want to ensure that that rudder is exactly perpendicular, or that vertical stabilizer is exactly perpendicular to the horizontal stabilizer. And you'll notice the rudder part hangs over the back of the fuselage, so it has room to turn, and of course the elevator has room to be adjusted up. Of course, we would pin more completely. And again, the alignment is critical. We want to use our guide marks there, so this is exactly, the horizontal stabilizer is exactly perpendicular to the fuselage. Next will be final assembly. Okay, now we're ready for final assembly. And the way we do that is to put a few pins through the fuselage and glue the wing in the appropriate place, putting the 2-degree pivot in that we talked about, and put plenty of pins through the wing. And I might mention with the pins, the hobby pins, these nice little plastic clamp accessories are made by Rocket City Specialties. It's their pin clamp, stock number 55. Very handy item. And when you glue this, we want the horizontal stabilizer and the wing to be parallel, except if you're going to have any misalignment at all, you want the left wing slightly lower than the right as compared to the horizontal stabilizer. When that's dry, you can glue your launch hook in. And now, since you carefully selected the lightest and straightest balsa fuselage piece, the next step is waterproofing your plane. That's absolutely essential, because as critical as the center of gravity is, and as porous as balsa is, any kind of dampness or wetness can cause troubles. So to waterproof it, we're going to use sanding sealer. And the best sanding sealer, especially for use with kids, is a water-based sanding sealer with a non-toxic odor. Now, I purchased one about 10 years ago from Ace Hardware, water-based sanding sealer. I believe it's no longer available, but my supply is still with me. On the internet, I noticed one made by J.W. Etcetras called the First Step Wood Sealer. Looks like it's available at hofcraft.com. That may be a substitute. And the idea is all the wood pieces, especially the fuselage, need to get a coat of sanding sealer. And oh, by the way, after the hook is dry, you're going to need to streamline this part on the hook. Everything, all the wood parts, nooks and crannies, get sanding sealer. After that dries, you need to give it a very light sanding with fine sandpaper. And if you have trouble, of course, getting in any nooks and crannies, you can use a little bit of a nail file, for instance, here. After that, give it a second coat of sanding sealer. When that dries, another light sanding with 400 or 600 sandpaper. And then it's time to purchase a brass strip manufactured by K&S Engineering to use for a nose weight. Or you can find something around the house that might work just as well, but they make a brass strip 1/4 inch wide, 35 1/1000ths of an inch thick. I believe it comes in a 12-inch length, so you cut off a piece of about 2 1/8 inches, and of course take a file and again streamline around the edges. And you're going to take that piece and tape it with a piece of Scotch tape to the nose. Tape it to the nose like that. And then it is time to check our center of gravity. Once again, the center of gravity is the most important aspect of an airplane, and the Flying Star outdoor catapult glider design has a couple of features that enable you to calculate, mark, and achieve this all-important center of gravity or balance point before your first flight. First of all, it has a constant chord wing, so that makes the center of gravity easy to calculate. And it's got a sufficiently long tail moment and nose moment such that you can accurately achieve the center of gravity. And of course, if we use this traditional 25% center of gravity that most airplanes use because they want to fly straight, our catapult glider would fly straight up and then straight down. We don't want that. Our goal is flight duration, so therefore we use the center of gravity back at 55%. So once you've attached temporarily the nose weight, you need to get a center of gravity device. You can make it out of foam like this with some erasers. You can make it out of wood, or I made one especially for this particular design like this. So you match this up, your markings, the center of gravity is marked on there. You line that up and see if it balances. If it doesn't balance and it's nose heavy, then remove the little Scotch tape, get a file, or otherwise shorten it. And at the same thing, if it's tail heavy and you need more nose weight, cut another piece slightly longer and try again. So keep doing that until you achieve the correct center of gravity as marked. And one little feature I added to this particular model was a little hole in the front here where I can add bits of clay if necessary to fine-tune the center of gravity. And I have you can make that, just take a twist drill. Since balsa soft, you don't need an actual drill, you just use a drill bit and on the low side of the fuselage, you can make a 1/8 inch hole in there, and that'll give you a cavity to use little bits of clay. But hopefully you can get this the right length. Then remove the Scotch tape, take some sandpaper, and rough up the side that is going to be going up against the fuselage to be glued. So you put glue on there, again Elmer's glue all, and you glue the nose weight to the fuselage. Then after that, it might be a good idea to recheck your center of gravity. And at this point, your plane is ready to fly. So our next segment of the video will be on flight trimming. One last item before we fly is the launcher. The launcher is made from a dowel approximately 1/2 inch in diameter, 5.5 inches long. To the dowel we add a screw eye available at any hardware store of appropriate size, and screw that eye into one end of the dowel. Therefore, the dimension from here to the top of the screw eye is less than 6 inches. And then we get a rubber band 1/4 inch in diameter from a length of rubber. Make a knot in it and attach it to the screw eye, and the length of rubber from here to here has to be 9 inches or less. Also, you can substitute 3/16 inch rubber with a slight loss in performance. Or if you can't locate the rubber, a length of 1/4 inch rubber, then, and a lot of times you have to find it online, as a substitute you can use 3 number 64 rubber bands, like so. It'll come out longer than 9 inches, so it doesn't meet the official rules of the Academy of Model Aeronautics, but if you're just flying for fun and not in a contest, this works okay. Not as good as the regular rubber, which is made for model aviation, but this will work fine. Now, the technique to attach either the rubber bands to each other or the rubber band to the screw eye is like so. Take this through here, and then this goes this way like that. And once again, you can add a coat of sanding sealer if you like. And that is the completed launcher. Okay, now that you're ready to fly, you need to find a large unobstructed grass field, ideally 600 feet by 600 feet square. And when you launch, you want to be sure there's no people close to you, especially in the direction of launch. You want at least a clear 200 or 300 feet with no people, because as us engineers say, all accidents are preventable. So if you have any spectators, have them a safe distance behind you and be sure they're watching you at all times. I would say put them about 200 feet back. So, on your initial flight, watch and what happens. If it loops If it makes a tight, complete loop, you probably have too much up elevator. So the best thing to do would be to make a slight tweak and push the elevator down just a little bit. Then try another flight and see if it improves. Also, you can experiment with launch angles. As I mentioned earlier, you can try a lower angle or you can try straight up. Straight up, sometimes even with a tight loop, it'll come out level as you desire and it'll start to make its left turn. If it doesn't turn to the left, try more left rudder trim. If it spirals down sharply rather than turning flat, try less left rudder. In other words, move the rudder in the other direction, reduce the amount of left rudder trim. Or another thing you can do is give it more right aileron to stop that tight spiral. Your goal is to achieve a flight of at least 10 seconds. If you can do that, you're a flying star. Now, to do better than that, choose a sunny day at about noontime when you have the maximum amount of thermal activity where the hot air is tending to rise, with the wind less than 8 miles per hour. If you take 5 or 10 flights, trimming as necessary, you should be able to achieve at least one flight of 20, 30, even 40 seconds. Once again, in conclusion, my name is Walter. I'm the volunteer creator and director of the Flying Stars Model Aviation program. The mission of myself and my fellow volunteers is to introduce kids to engineering through model aviation. And I wish you the best of success.